Could you look inside ChatGPT and find out what does it know and think? Due to the nature of their training, language models often answer in a way that agrees with users' biases and preferences rather than report the truth. Moreover, what if the AIs get so much better that we cannot verify the truthfulness of their output? Is there still some way how to uncover what language models consider to be true? Well, a paper by Colin Burns and co-authors titled Discovering Latent Knowledge in Language Models Without Supervision tries to make progress on exactly this problem. So let's dig in. First, to make our task a bit easier, let's consider only yes or no questions. Once we have a large data set of these questions, we can turn them into statements with the opposite truth value just by simply appending yes and no. For example, are dolphins mammals? Yes. And are dolphins mammals? No. Now we may feed all those statements into the language model and store all the activations of network's neurons, which we will denote phi I plus and phi I minus. The set of all activations for a given input is like a brain scan of the model, so if the models does have some concept of truth, that information should be somehow contained in phi I. But the activations are just a plethora of numbers without any interpretable meaning to us, so how can we make sense of that? The key idea of Burns and co-authors is to use the activations to estimate the probability that the language models assigns to each statement being true, p plus and p minus. To learn these probabilities, we will use another model with parameters theta. This auxiliary model is typically much simpler than the LLM, whose activations we are examining. The question then is how to choose the parameters theta for the auxiliary model. To answer this question, it may be useful to pause and think about what we want from p plus and p minus. First, the learned probabilities should be logically consistent. Since we are considering only yes or no questions, it implies that p plus and p minus should sum up to 1. For example, if I think there is 70% probability that dolphins are mammals, I should give 30% probability to dolphins not being mammals. However, this will not work on its own. Consider if we simply assign 1/2 to all the probabilities. In that case, consistency is satisfied perfectly, but we won't learn anything about what the language model knows. To avoid this, we can incentivize finding statements that the language model is confident about. That is, we want the larger of the two probabilities to be as high as possible. Taken together, we will train our auxiliary model on many of these statements and choose theta to achieve both high consistency and high confidence. Since its release, this paper has received a lot of attention. While some have built on this approach, others have argued that this entire research agenda is a dead end. If you are interested in exploring further, the links to those other papers and blog posts are in the description to this video.